Okay, so this is the second computer skill lecture for this chapter. So we're going to look at a business case called the Subaru's Outbacks. And so in the previous video, we already learned the technique-wise how to do the two-tail test, left tail, right tail test. So for this one, actually, we just apply those steps to answer actually a business problem. So as we walk through this problem, I also want to calling out a very helpful tool Dr. Jiang developed on D2L. And I really highly recommend you use this to help you on your homework assignment and also get really familiar with this so that when you get into our exam, you already know how to use it, right? So on this, it is under our this week chapter 9.1 sample hypothesis testing lecture and learning material, and then when you go there, you'll be able to see this called hypothesis testing cheat sheet. So this is a very helpful tool. You can even just print it out. Okay, so here I'm already laying out if you want to use a critical value approach, the formula you need to use, and then also the Excel formula you should use, etc. If you want to use a p-value approach, so what you need to do. Okay, and also it's also allow you to set up the hypothesis. If you know you are testing two-tail, left tail or right tail, you will know and what kind of hypothesis it should look like. Okay, so as we walk through this example, I definitely want to show you how you can leveraging that cheat sheet to finish this problem. Okay, a small dealership learned 21 Subaru's Outbacks on second-year leases. When the car were returned at the end of the lease, the mileage was recorded on Excel file supplied. And so this is the question number 2. If you go to the tab number 2 and you are able to see all those records from the 21 vehicles. Okay, continue. And so the mileage was recorded on Excel file supplied. Is the dealer's mean significantly greater than the national average of 30,000 miles for 2-year lease vehicle using the 10% level of the significance? Okay, so there are a lot of information to need to unpack here. Okay, so first of all, you need to ask yourself, is this a two-tail test, left tail test, or right tail test? So you are immediately going to notice that this should not be a two-tail test because there is the direction of the relationship already been defined. That is the dealer's mean greater than the national average. Okay, we are testing if dealer's mean, this mileage mean, is greater than the national average of 30,000. So therefore, that 30,000 miles gonna be our hypothetical value for the mean of the mileage. Okay, so now since it's not two-tail, we need to define if it's the left tail or right tail. Okay, so as you're reading here, the dealer's mean significantly greater than the national average. So if I use in my Excel, I put on that sentence. What you are trying to testing is if it's the mu, which is the mean, is greater than, right, which is greater than 30,000. Okay, so if that's the case, remember there's two reasons, which one is HO, which one is H alternative. So one reason is that a simple way, because the status quo is that we should follow the national average. So therefore, this is should not greater than the national average, should be what we are trying to settle as H non, because that's the status quo, right? And so the other reason we know what we're listing here has to be our H alternative. Okay, so we are trying to challenge in the status quo. So it's also because as you list here, there's no equal sign. So Dr. J has mentioned in a regular lecture, that the H alternative, HO, your null hypothesis, always has to have that equal sign. So given what we are trying to solve here, there's no equal sign involved, so this is going to go into your alternative hypothesis. So both approach support what we read from the question here is my H1. Okay, so my H1, okay, let me go back here. So my HO will be mu smaller and equal to 30,000. That right? Yeah, 30,000. And then so that is the status quo. In the H alternative, my H1 will be mu larger than 30,000. So we try to using the sample data we collected to prove if we are able to reject HO and then to conclude that the dealership does have significantly higher than the national average 30,000 miles. Okay, so now after you set up your step number 1, okay, this is your hypothesis. And then you can leveraging Dr. J's cheat sheet here to see, hey, am I looking at the two tail, left tail, right tail? Okay, so since if you look at what we just listed here, we are testing H alternatives mu larger than 30,000. So mu larger than 30,000. So therefore, we are working on this right tail test because mu larger than the hypothetical value is 30,000. So therefore, all the step you're going to work on is follow my third column here. You can use the critical value approach or you can use p-value approach, depends on the question. Okay, so this is a very important step. Define which test you are working on, right tail, left tail, or two tails. Okay, now we know we are working on the, so this is the right tail test. Perfect. Now we are going to documenting all the information we needed to calculate the t-stats, right? We learned that regardless you use the critical value approach or p-value approach, you always need to follow this formula to calculate the t-stats. So in order to calculate t-stat, you need to get in the value for the following information, the sample size. Okay. So first, we need to know the sample size, although we know it's 21. So you also can use the formula called the count. And then select all your numbers without including the label. Okay, so you count how many? 21. Not surprising, we know it's 21. And then next, we calculate the sample mean. We use average. So we already learned this before. And then we select my data. So that's going to give me the sample mean. Now we are going to the sample standard deviation, which is stdev.s. Since we're dealing with the sample, we make sure you have .s. And then select my sample data. And then that give me 11,866.2. Okay, so that's my sample standard deviation. The hypothetical value is the 30 miles, right? So based on the question, we try to test if this average we see here gonna be actually statistically larger than 30,000. Okay, now we have so the alpha. Forgot this one. So if you look at the question, the test is a 10% level of the significance. So therefore, the alpha here is 0.1, 10%. Okay, now we can start to calculating our t-stats, right? We starting from the critical value approach. So for the t-stat, first follow this equation, calculating my standard error, which is the denominator here. So it's equal to the standard deviation we calculated and divided by square root, SQRT, square root of sample size n, close the parentheses. So that's give me the denominator of my t-stats we try to calculate here. We also call it standard error. And now we can start calculating the t-stats, follow the exactly formula here. We first start, we use the sample mean. So equal sample mean minus the hypothetical value here. Oh, I forgot the parentheses. This is very important. Don't forget about the parentheses. And then divided by the standard error we just calculated. So that gives me the t-stats. So the t-stats equal to 1.52526. Okay. Now let me go back to my cheat sheet again. Okay, now we finish calculating the t-stats. Step number 3, we're going to figure out our critical value because we need to base on the critical value to figure out should we reject HO. So the good thing here is that I already give you the idea how to use Excel to calculating the critical value for the right tail test. We just need to use a t.inv and 1 minus the alpha value and the sample size minus 1. Okay, we're going to follow this equation Excel file to calculating the critical value. Okay, let me go back to my Excel. So critical value, okay, we can put down here is, this is the right tail. So this will be t dot inv parentheses, the probability is 1 minus the alpha, right? And then the second entry is the sample size minus 1. Okay, then I will be able to push enter. So I received the value 1.325. Okay, 1.325, that is my critical value. So how do we know if we reject or not? Cheat sheet again. We're looking for if the t-stats we calculated is larger than our critical value, then we will reject. Okay, so we're going to come back here. Rejection rule is if t stats larger than right tail critical value, reject HO. Okay, now if you look at what we have here, okay, the decision. So the t-stat is 1.525. It is larger than 1.325. So therefore, the decision is reject HO because the t-stats 1.52 is larger than critical value 1.32. Therefore, this is going to be our conclusion. The mean mileage for this dealer is statistically significantly larger than the national average 30,000. Okay, 30,000 miles. Okay. So unfortunately, this dealer ended up had the customer really love driving. Okay, so this is the first approach. How about the second approach? Second approach is p-value. So we are gonna have the same first step. So I'm gonna skip that. Okay, the first step still be the same. For the second step, we're gonna calculating this p-value. Okay, so it's the right tail p-value. Okay, now if you go back to my cheat sheet I created for you guys. Okay, scrolling down here. So for the p-value, we're going to using this t.dist.rt and select t-stats and the sample size -1. Okay, so we're going to use this method for that. Let me go back to the Excel file. Okay, equal to t.dist.right tail parentheses, and the x is the t-stats we already calculated, which is here. Okay, so the t-stats. The degree freedom is the sample size -1, and the close the parentheses, that are going to give you the p-value. Okay, so the p-value here we receive is 0.07143. Okay, now this is step number 3, the rejection rule. Okay, using the cheat sheet again. So if the p-value we calculated is smaller than the alpha, then we will reject. Okay, so we come back to my Excel file again. Okay, reject HO if p-value smaller than alpha. Now let's see, shall we reject? So the p-value calculates 0.07 and the alpha is 0.1. Therefore, our p-value is smaller than our alpha. We need to reject. So therefore, your conclusion is reject HO since p-value 0.07143 is smaller than 0.10. Okay, we get the same conclusion. Therefore, the mean mileage for this dealer is statistically significantly larger than the national average 30,000 miles. Okay, so here they go. And so hopefully you know how to leveraging that cheat sheet Dr. J created for you to work on the homework, and also down the road you can work on your test. So good luck with your learning. Bye.